Hello Internet, this is JF, and I suck at ATS. Let's just emit a happy little tuple. So tuple 2. You can get the sense from the name of this function that it's meant to be internal, like sort of an internal use one, but it's still a part of the library. If it'll work. That totally doesn't work because I forgot that this is actually a template. You gotta tell it the type. So it has logic for printing out tuples that have two elements to them. But you have to tell it what types they are. So the string and it. There it goes. Oh yeah, we probably want to print out a new line as well. There you go, a happy little tuple. Now this is a little bit awkward. All the tuples look the same, so it's like they've all worn the same dress, or they're like twins who haven't found a way to differentiate themselves. So they look a little bit different. Unfortunately, though, this is it's a function, like it has like code in it for the open parenthesis and the comma and the close parenthesis. So if it were like generic code, you'd have to like pass it arguments, like, oh, it looks something like this, the comma, close parenthesis, like that. But that'd be tedious. I mean, you could have like this short template that calls one that's longer. Like that's what you do in something like Erlang or Prolong, where there's where functions can have different arities, and that ATS can sort of have functions with different arities with the same name using the overloading system, but normally you probably wouldn't want to do that normally. It's still tedious. No, actually, this is a reasonable way to do it. So that's one way. One way you wouldn't want to have like a separate you wouldn't want to have state stored somewhere because you're gonna have action at a distance. Like you wouldn't want to say, okay, well let's go ahead and say a weird tuple, and then after doing weird tuple, like tuple will print out different stuff. Like you could do that with like you can have like references that store strings, and weird tuple could replace those and so on. You have like a normal tuple that resets it, but there's another way to do it. It's fprint tup begin. That's not printing, is it? It probably takes a reference. So fprint. Oops. And what would that be? Separator. Let's try that. Fully. Oh, you have to implement it like this. There you go. One thing to notice there is you've got these two tuples. They're printed out normally. They're the same, but this one benefits from these implementations. So that means, like I've done it before, like you work with higher order code where there was a template that expected another template to be implemented but didn't actually implement it. This is a case where there is an implementation of like begin and separator and end, and they have the default code, but you can override it when you use this template. So you can output tuples that look a little bit different. All right. And of course, just the same way we've got this where applying to this parenthesized expression, including the print and the new line. You could have the where you have that go over multiple lines. So you could say like something like this. That's all very neat, but that works. What if you wanted to have like a normal one between the two? So you want to apply to like this one and this one, but not not this one right here. That's between them. Otherwise, you just duplicate this where and have it on both of them. But of course, that's code duplication. That's kind of lame. So there's another option. Let's make this a header file. It's going to be came with a good name for it. That's all this file has. It has 3 implementations. And now, instead of having these in here, you could say, where include weird tuple.hats. And do that here as well. What did I call it? A weird tup. Yep. So I've got a weird tuple and a normal tuple and a weird tuple. So you can have includes that are localized. I can do the same thing with like let. Like I could have this might actually look a bit nicer. So at the end there. Yep, that works as well. And this include it's not a C preprocessor. It's part of the language. It includes the hats and it scopes it just to these expressions. Just like the where scopes it to just this this parenthesized expression that the where covers. All right. As an example of a thing you can do with not with tuples, with templates. So you can make like a perfectly normal function that prints out a happy little tuple, the string and an int, and you can make it generic with the ability to for somebody to go by after you and change some things, just by saying instead of like making a normal function, just make a template, just make your tup. Just make a template that doesn't take any types. It's just an argumentless template, and people can change that after the fact. And this won't cost you anything at runtime. Actually, it'll be cheaper than if you'd had like a function call potentially. Another place we should use templates is instead of polymorphic functions. Not in general, but if you're going to have a polymorphic function with like, let's say, I had one from yesterday, didn't I? Yeah. Not the C code. This code. Length my vect. This right here is a polymorphic function, and it's a polymorphic function over a type that ATS doesn't know the size of. So that's what this is. Like this is what it literally says. It's just I don't know how big that is. I don't know what kind of size it is. It could be like a 10. It could be an array of like 10 ints. It could be huge, or it could be just one pointer. If you want to have polymorphic functions, you have to polymorphic functions. If you want those, make sure it's always over a size that's statically known. So type, not the type with the at it. If you do want to have something like this over something that's other the size is unknown, then always make it a template. I'll go and show you why it should always be a template. So that works. But notice that I have optimization level 3. Let's say it's optimization level 1. Segfault. Yeah. It breaks. You notice it breaking down there, but just in general, you're not actually supposed to do this. So don't do that. It works just as well with it being a template. Or again, there are actual benefits to it. In fact, I probably wanted to have like a video called like use templates, use templates, use templates, use templates, because they're a big part of what makes ATS a good language. And also they solve so many problems and they give it so many capabilities. So one of them is you get code that people can change, like with late binding after the fact. They don't have to like monkey patch an object and change it for the entire language. They can change it just for a particular use. And then you get code that's like polymorphic over types that the language can't be polymorphic over normally. You just have to name the type. And of course, naming it also solves some problems. So yeah, that's the video.